Hello everyone, welcome back to CloudYeti YouTube channel. In this video, we are going to learn about Amazon Elastic Container Service or ECS, which is one of the container orchestration services you can use on AWS. Let's take a look at some ECS concepts first, and then we'll jump into our hands-on lab. Hi, I'm Robin Gautam, an AWS certified cloud and DevOps engineer, and I'll be your presenter today. Now before we begin, I will quickly go over the definitions of containers. So what are containers? Containers provide a standard way to package your application's code, configurations, and dependencies into a single object. Containers share an operating system installed on the server and run as isolated processes, ensuring quick, reliable, and consistent deployment regardless of the environment. One of the goals of modern software development is to keep applications isolated from each other. One way to do is using the virtual machine. But the virtual machines are bulky. Each requires its own OS, so it's typically gigabytes in size and difficult to maintain and upgrade. Containers, by contrast, isolate applications' executions environment from one another but share the underlying OS kernel. Containers are a standardized unit of the software that allows developers to isolate their apps into its environment, solving "it works on my machine" headache. They are typically measured in megabytes, use far fewer resources than VMs, and start up almost immediately. Containers provide a highly efficient and highly granular mechanism for combining software components into the kinds of applications and service stack needed in modern enterprise and keeping those software components updated and maintained. So now we know what a container is, let's move over to Docker. So Docker is the open source platform to build and share containerized apps. Since it doesn't require a hypervisor, unlike VMs, it's lightweight. In 2013, Docker introduced what would become the industry standards for containers. Docker is the de facto standard and platform to build and share containerized apps from desktop to the cloud. Docker containers are runtime instances of Docker image. So let's talk about some components of Docker. Docker file. A Docker file is a text document that contains all the commands that is used to build an image. Docker images is comprised of multiple layers that is used to execute code in a Docker container. Container. We just talked about the container earlier. Docker CLI. Docker CLI can be referenced as command line interface provided by Docker client to interact with the Docker daemon. Docker daemon. Docker daemon does all the heavy lifting of building, running, and distributing your Docker containers. The Docker client and daemon can run on the same system, or you can connect a Docker client to a remote Docker daemon. Docker Hub. Docker Hub is the repository to store Docker images. Docker Compose. You can manage your multi-container based applications upon the configurations in Docker Compose file. So now we have understanding of what a container and Docker is. Let's take a look at Amazon Elastic Container Service or ECS. ECS is a native service in AWS that helps you manage, scale, and provision container-based applications in the cloud. It is orchestration service for containers. Some other options for container orchestrations are Docker Swarm, which is an open source orchestration developed by Docker, Kubernetes, which is another open source container orchestration service developed by Google. Then all the major cloud providers also have the managed Kubernetes offering. On AWS, they have EKS or Elastic Kubernetes Service. In this video and in this series, our focus is going to be containers with Amazon ECS. Let me know down in the comments below if you are interested to learn about EKS. So coming back to ECS, imagine ECS is a service that simplifies running containers in a highly available manner across multiple availability zones within a region. You can create a ECS cluster within a new or existing VPC. After a cluster is up and running, you can create a task definitions that define which container images to run across your cluster. Your task definitions are used to run tasks or create services, and we'll be discussing that further. Container images are stored in and pulled from container registry. For example, imagine Elastic Container Registry. So the components of ECS includes service, tasks, and containers. We now know what are containers and what is ECS. Let's take a look at what are tasks and services in ECS. In ECS, we have a thing called task, which is a wrapper to run your container. In order to run your task, you need to specify the task's definitions, which specifies what containers are going to be run. On the other hand, services will run tasks based on the task definitions. It will also bring up the new task in case your task terminates or gets stopped. You can furthermore specify things like load balancing, security groups, and auto-scaling using the service. Most developers use Docker Hub for storing their Docker images. Docker Hub is one of the repositories you can use to store container images. There are millions of images that you can find on Docker Hub. You can even build your custom images and push to Docker Hub. Private images require subscription. AWS has Elastic Container Registry or ECR, which is also the repository where you can store your images. Furthermore, you can scan those images for vulnerability checks. ECR images are hosted privately and you can manage access permission to user using IAM. The cool thing is it's integrated with ECS and ECR is very cheap to use. Now let's discuss about ECS launch types. We have basically two options where we can choose the launch type options in ECS. We have Fargate launch type and EC2 launch types. EC2 launch type uses EC2 instances for running the ECS service or task. Fargate launch type does not require EC2 and is sometimes even called serverless container. In this video, we are going to cover the Fargate launch type. Let me know in the comments below if you are interested to learn about EC2 launch type as well. Fargate has less customizations and options compared to EC2 launch type, but it has other benefits. For example, there is no need to patch and update your operating system on the host machine. So now we are done with the basic concept. Let's get started over AWS Management Console. So on AWS Management Console, let's go over to the ECS service. In this video, we are going to create an Amazon ECS cluster from scratch using AWS Management Console, and in next video, we are doing everything using ECS Compose utility, which we'll be discussing further in the next video. Let's click on Create Cluster, and we'll be prompted to choose the cluster template. Let's select Networking only for AWS Fargate, and click Next Step. Over here, we need to provide the cluster name. Let me name it CloudYeti cluster and hit create. So you can see we have our cluster over here. So we have our CloudYeti cluster, which has no resources yet. It doesn't have any running task or services. Note that in Fargate, you don't have to rely on dynamic port mapping as each task gets its own IP addresses as well as has unique ENI per task. So once we have our cluster ready, let's go to our GitHub repository. And I'll be linking this repository link in the description below. So once you're in this repository in part 1 directory, you can see the readme file that contains a list of steps that we are going to follow along. So let's get started. So we already created our cluster. So once we have created our cluster, the next step is we are going to pull the image from the Docker Hub and push it to ECR. So let's do that. So let's copy this command and paste it over here. Now this command pulls the Nginx image from the Docker Hub. So once you have pulled this image, you can run docker images command, which shows the images that just got downloaded. And if you see docker ps, and with docker ps command, you see we don't have any container running yet. So now we are going to run the container out of that Nginx image, and we have this -d flag to run our container in the background. So if I copy this command and paste it over here, you can see using docker ps command, our container is running over here. Now if you go to the browser and click on localhost, you can see our application is listening on port 80. So the next step is to push our image to ECR. So in order to push image to ECR, you need to have AWS CLI configured. And you can follow along this link if you don't have configured AWS CLI. Now note that if you copy the ECR push command from AWS console, you don't need these steps, but it's good to have anyways. So what I'm going to do is I'm going to copy this on my terminal. And on the account ID, I'm going to give my AWS account ID. So you can find your account ID on these account sections. So once you have entered the region and account ID, let's follow through the next steps. Now the next step is to create a repository with the name of CloudYeti Nginx. So I'm going to copy this and paste it on the terminal. You can see our repository is created. Now you can always go and verify in the ECR. So once you go over to ECR, Elastic Container Registry over here, so you can see we have our repository created, but inside it still we don't have any images. So we need to push our image. So coming to our GitHub repository, in order to push the image to ECR, we must create a tag, login, then only we are permitted to push our image. So let's enter this command in order to log into ECR. You can see we have a message saying login succeeded. Now the next step is to tag our Nginx image. For that, let's copy this command and paste on our terminal. Now if you do docker ps, you can see our container ID is over here. But if you do docker images, you can see it's tagged with the new tag over here, but the image ID are the same. So the same image is being tagged with this naming convention. Now we are going to push our image. So for that, we'll just copy this command and push our image to the ECR. So you can see our image is being pushed to ECR. So in order to verify it, let's go to our ECR. And if we refresh over here, we can see our image is there. So now let's go ahead and create our task definition. So in order to create a new tasks definition, let's go to our ECS console. Let's click on the tasks definition. So let's click on create new tasks definition. We are going to choose the Fargate mode. In the tasks definition name, let me name Nginx tasks definition. Let's scroll down, and on the task size, we are going to choose the minimum requirement. And let's click on add container over here. And I'm going to give the container name as Nginx container. And on the image, let's provide the URI of our ECR. So let's copy the URI and paste it on the image. So with this, ECS can pull image from ECR. But if you wanted to pull image directly from Docker Hub, you could do something like this. On the soft limit, let's give 300, since ECS recommends 300 to 500 MIB as a starting point for web servers. On the port mapping, let's specify 80. You don't need to provide host port and container port separately, unlike the EC2 mode in Fargate. And when you scroll down over here, so over here you can see we already have our log configuration in place, which helps to see our log on CloudWatch. So let's click on add. So you can see the message over here. It says network mode is AWS VPC. This is the default mode in Fargate. So let's create our tasks definition. You can see our Nginx task definition is succeeded. Now if you go to tasks definition, so you can see our tasks definition is in active state. So let's go back to our documentation. So we just created our tasks definition. Now the next step is we are going to run a new task. So for that, let's go to our cluster. Let's click on our cluster name, and on the tasks tab, let me click on run new task. And over here, let me specify the Fargate launch type. So you can see on the tasks definition, we have a thing called revision. And here I have selected 2. If you have tried for the first time, for you it should show 1 with the same name. Since I had tried with the same name in preparation of this video, I have the second revision over here. And down here, I want to choose my VPC. So let me choose my custom VPC that I had created. Now I'm going to choose 2 public subnet associated with that VPC. So let's leave auto assign public IP as enabled and click on run task. You can see our task is in provisioning state. Soon it will be in pending state and we can see it in running state. You can see our task is in running state. So once your task is in running state, let's click over this hash over here. And you can find our public IP over here. Let's copy this public IP and you must see our application up in Fargate. So you can see we have successfully launched our web application in Fargate. So let me go to our GitHub repository over here. You can always find the list of steps that we followed along in this README file. So the next step that we are going to do is to create a service. Service helps in keeping our task highly available, and we'll see how. So on the ECS console, let's click on our cluster. And inside our cluster, you can see there is a service tab. Let's click on create. Let's select the Fargate launch type. And you can see we have to provide a service name over here. Let me provide Nginx service. And I need to specify the number of tasks that I want to run for the service. So let me select 1. So let's scroll down and click on next step. So over here, let me select the VPC. So this was the same VPC that I had chosen for my task definition. So let me click on 2 public subnets. So when you scroll down, so you can see we can configure the load balancer within the service, but we are not going to deal with load balancer creation in this video. So let's go ahead and click on next step. And on the next step, you can see there is an option to set auto scaling. So we are not going to do auto scaling configuration as well. Let's click on next step. And let's click on create service. Now you can see our service is being created. When you hover to task, you can see this task is attached to our service. And when you click on this task, you can always verify that our application is running. Now we are going to see the use case of service. So even if we stop our task, or for some reason if our task gets stopped, our service will bring our task back. So let's see this use case. So if I stop this task, and if I refresh over here, so you can see our service brought up the new task over here, and you can see it's in the group of service. So if you have the task attached to the service, even though you stop your task, our service will bring it back up. And we remember the below tasks definition, which is not attached to the service. So what happens if we delete this task definition? So if you delete the tasks that's not attached to the service, it's not going to come back. And we can take a look at it. So let me stop this task. And you can see it's not going to come back. This is the task which was attached to our service. but you are not going to see the another task. So this concludes the use case of services and how crucial they are in order to have your task up and running all the time. So there are furthermore things that I wanted to show over here. So those things are logs. So how do you track on logs in ECS? So there are few ways to track the logs in ECS. So if I click on one of my tasks over here, you can see there is a logs tab. If you click on this logs tab, you can verify our logs over here. And similarly, you can see the events on the services. So if we go back to our cluster, and if you click on our services, and if you click on our service name and go to the events, so on the events, you can see the activity history about when your task got created or when your task got stopped, things like that. There is one more interesting thing over here. If you go to CloudWatch, on the log groups, you can see in the name of our Nginx task definition, we can see the log streams over here. And if you click on any of them, you can see the timestamp and the messages and logs about the container. So with this, we conclude our ECS Part 1 series. Hope you like this video. We'll see you in the next lesson where we'll see how to automate all of these things using some kind of automation tool or CLI. See you in the next video. Thank you.